Hello students, welcome to etechtales, and today we will begin with the next portion to where we left. We will start with derivatives. So as we know, derivatives is a portion of pure mathematics. If you know, we have to get familiar with equations here, which we will be correlating with managerial economics. There are certain definitions, the slope, etc., which will denote with the help of derivatives and regression analysis. Okay, so when we talk about the slope in mathematics, we are referring to the concept of marginalism in economics. Slope, in the sense, we were familiar with this definition: y is equal to y into x. Okay, where dy by dx, it was representing the change in y as a result of one unit change in x, okay, which we call the marginal y of x. Okay, this we actually know when we were doing this in our basic bcom or in graduation or pre-graduation, like in class 11, 12. So managerial functions are they are derived from derivatives of these total functions. Okay. So this slope or managerial function has enormous use in managerial economics. They are extremely useful further, because in the later half of this chapter you will get to know a lot about derivatives. They are full on with derivatives actually. Okay. So managerial functions, they are derived from derivatives of the total function. So they show the rate of change of the total function with respect to one variable while keeping other variable constant. In this definition also, you have to keep one constant and another one becomes the variable. Okay, so these functions, they are essential for analyzing the incremental impact of changes in one variable on another. So if one unit change in one variable, how much will it impact on the other? So this is useful when we use it with managerial economics. Okay, so these functions are essential for analyzing the incremental impact, as I said. So let's start with the types actually. Then it will be more easier for understanding. So let's consider the total function fx, where representing a certain economic relationship like the total cost, then total revenue, then the total production q. Okay, total cost is denoted by tc, total revenue by capital tr, and total production as capital q, which is a function of a single variable x. Okay, so we will change these variables and try to understand that how it is impacting the total cost or total revenue or the total production. Okay, so the marginal function with respect to x is denoted as f dash x, f slash x, in say you can say that, or df by dx. So this denotion here, this is somewhere similar to what I can say. Okay, and represents the derivative of a total function with respect to x. Okay, so when in the marginal cost came, if the total cost function is tcx, the marginal cost function is mcx. Okay, is a derivative of total cost function with respect to quantity. So mathematically we can say, write it here, Okay. So this is the formula. Similarly, we can say for this also, for marginal revenue in this scenario, the total revenue function TRX, the total revenue function TRX represent the derivative of total revenue function with respect to the quantity that is sold, X. So X is the quantity that is sold. Okay. So here we can say MR X equal to D TR X by D. Let's try to correlate this. Marginal cost, total cost. Marginal revenue, total revenue. Okay. Similarly for this also, marginal product MP. This is related to price. Okay. I'll say in the case of the production function QX, the marginal production function MPX is a derivative of total production function with respect to the input, that is labor or capital. So it can be in terms of labor, that is quantity, and capital, that is amount. Okay. So we can say here MP equals MPX equals DQX by DX. Q is the quantity. Okay. Q is the quantity. Quantity for the total production. Q. Okay. So relate like this. I'll rather say marginal cost, total cost. Marginal revenue, total revenue. Marginal product, total production. Okay. So in this way you can remember the equations easily. Okay. So these functions, they are crucial in managerial economics. So managerial economics, marginal cost, that is MC. It signifies the additional cost incurred by producing one unit of output. Okay, this is the additional cost. Always, whenever you are studying marginal functions relating to any, this is always the additional cost or additional revenue that is incurred when you are producing one more unit of the output or product, whatever. Okay, so the firms, they aim to equate MC, that is marginal cost, with marginal revenue to optimize the product, optimize the profit of the product, optimize product. Okay. So marginal revenue, it represents the additional revenue. Okay. Always, whenever you are studying marginal cost, marginal revenue, marginal product, it is just the additional portion. For marginal cost, it is the additional cost. For marginal revenue, it is the additional revenue. And when for marginal product, it is the additional quantity or output. Quantity of output. Okay. Let's read this in better way. It represents the additional revenue gained by one selling of one unit of product. It helps to firm determine the optimal quantity to produce or sell. So with this you can understand what quantity you need to make. Okay. So for marginal revenue, this is the situation. So for marginal product, it is the additional output gained. Okay. By employing one more unit of input. So it's vital to determine the most efficient allocation of inputs in the production. So understanding these marginal functions, this helps the manager making better decisions regarding the production levels, for pricing strategies, for resource allocation and profit maximization by assessing the impact of these incremental changes in one variable on the output, total output, or the total cost, or the total revenue. Okay. So just try to remember from this portion, that is the easy one. Try to relate the link here. Remember this linkage. For marginal cost, it is total cost. For marginal revenue, it is total revenue. For marginal product, this is total production. Okay. So this is the important portion here. This mathematical expression. So in question, they ask you about the what are the different functions of production. Okay. So we will be considering this total function fx, where we will be using it to ascertain certain economic relations such as total cost, total revenue, total production. Okay. Here it is being elaborated just to make you understand the mathematical expressions above. Okay. So let's move to the partial derivatives. It is easy. I'll always say derivatives portion is one of the easiest portion. If you understand it well, or if you know the the principle and the mathematical, the formulas and everything. Okay. But if you don't know, I'll be helping you out in the subsequent classes as we try to face them. So partial derivatives here, they are the fundamental concept in calculus that deals with finding the rate at which a function changes concerning one of its variables while holding the other variable constants. Okay. So we have to hold all the other variable constant, and with that we are going to find out the rate in which the function changes. So in essence, it's the derivative of a multivariable function. Okay. Which is concerning one variable treating the other variables constant. So if you go into this portion only, you'll understand that, like, in certain scenarios this will become a constant. Okay. This will become a constant. So whenever you're trying to find a df by dx, then in that case the answer to the variables will be like another variable will become a constant, and the answer will change. Okay. Partial derivatives is like half. Partially we are going to make the variables constant. Variable cannot be like constant all the time. Variables are those which changes with the change in x or y, whatever you are taking. Okay. But here they will be constant. So that is partial derivatives. This is not much, this is not at all in your syllabus in an elaborated way. So do not worry about this portion. Okay. This is an advanced calculus portion, I'll say. Okay. So next is optimization concept. Here, optimization is the act of choosing the best alternative out of the available ones. It describes how decisions or choices among alternatives are taken or should be made. So all the optimization problems have three elements basically. Okay. So here I'll just making you say all these things. Okay. So again I'll say that optimization is an act of choosing the best alternative out of the variables. So here we will choose among the alternatives, and we will optimize the elements, optimize the problems into these three elements basically, that is the decision variable, the objective function, and the feasible set. Try to remember this because this is an important thing to remember. Okay. So we are trying to narrow down the concept when we will be optimizing and choosing the best alternative out of the available ones. In case of like in we were doing an opportunity cost, wherein we were trying to analyze the best option out of the available ones. Okay, we're trying to optimize here. So these variables, they are here. So in decision variables, what happens is these are variables whose optimum values must be determined. So for example, the production manager, suppose he wants to know the level of output that will achieve maximum profit or sales revenue. So he wants to know how to get maximum profit or sales revenue. So he wants to know the level of output. So here the output is the decision variable. So we are focusing on decision that is variable. So similarly, in the case where labor is there, machine time is there, or raw materials are there, they among them we have to choose. They are the choice variables. If a work manager wants to know the optimum amount of use of or use to produce a given output level of minimum cost at minimum cost. Okay, so these are choice variables again. Okay. Okay. Output is decision variable, choice variable. The another name that you can say for this is choice variable. Okay. So, yeah, the quantity of any choice variable must be a measurable one. So here you can it should be a measurable quantity or quality or hours or whatever, like 20 kg, 5 labors. Okay, 10 hours is needed, like that. Okay. So the objective function, if we come to, it's a mathematical relationship between the choice variable and some variables whose values are to be maximized or minimized. Okay, whose values you are keeping one constant and using the another one to increase or decrease, like that. Okay. So for example, the objective function could relate profit to a level of output or cost, cost to the amount of labor, machine hour, say then raw materials, etc. Objective function is specific for objectives functions only, which will relate profit to level of output or cost to amount, level of output or cost to amount, like in terms of money or in terms of output quantity. Okay. Objective is what do you want to change. Okay, like if you are changing the if you are relating this with your choice variables, it has to be related to another one as well, like mm, suppose what is the change in quantity if I change the number of if what I mean to say is what is the change of quantity of sales, suppose if we change in the time duration for making the product. Okay. So for like if you devote more time in making the product, then there can be a chance that there will be like the output stock of any product will be a lot and it is accumulated, so the stock will be high. Okay, so one will result in increase of the another. That is what is objective function. Okay. The feasible set here, this is a set of variable available alternatives. A solution to an optimization problem is a set of values of the choice variables within the feasible set of yields the maximum or the minimum value of the objective function. Feasible set is the combination that you're trying to make between the decision variable and the objective function. Okay, you're trying to set standards for your production. Like, this is, if I want to make this much of profit, I have to make this much of raw materials, or we have to devote this number of labors for the process of getting the products. Okay, so this is a set. So in case of unconstrained optimization technique, for this, involving a single independent variable is needed. We need it to satisfy certain condition. Okay, so like in first order, second order, third order derivations are there. So like that only. So you must have done this before. I hope that you are familiar with the terms that first order derivative, then second order derivative is like. Okay, so here also we will be using them mildly, not at all in a very depth way, but mildly. Okay, so in economics, the necessary first order condition is called the equilibrium condition. First order is equilibrium condition. Okay, and sufficient second order condition is called the stability condition. Please write it down beside, like I am writing. That is a continuation of a state of equilibrium. So we are stable in that way. Okay, so these may be equilibrium, but it may not be stable. So that is the, so the first order the condition does not guarantee second order condition. Sometimes it can be like the first order, that is the equilibrium condition is there, but it is not sufficient to make it stable. Equilibrium is there, but that is not sufficient actually. Okay, just remember these two, they are important. Okay, so understanding this concept of derivatives, the partial derivatives, and optimization, this will provide you with the different tools that is needed to make this informed and effective managerial decisions in the upcoming time. Okay, so we will end the class here today. In the next class, we will begin with the remaining portion. Okay, thank you.